we want to find the slope of the graph of 3 quantity x squared plus y squared squared equals 100 times xy at the point 3, 1. So the first thing we have to do is find the implicit derivative of that equation.
General power rule?
Yes, I guess the left side we could do with the chain rule, right, you guys? If you have a parentheses to a power, that's what we have on the left side, right?
Right.
So we could do power times coefficient, which would give us 6, down 1 on the power, times the derivative of the inside, which is 2x plus 2yy prime. Okay, so that's the derivative of the left side. We'll kind of just hang out for a second and make sure everyone is good with that. That's just the chain rule. Any questions on the left side of that derivative? Power times coefficient, down 1 on the power of the parentheses times the derivative of the inside of the parentheses. Okay, now the right side you need to be careful about, and this is one of the biggest errors people make. You cannot take the derivative of the right side without using the product rule. Because you have 2 variables multiplied together. You have 100x multiplied by y. So you have to use the product rule anytime you see an xy. So it is a multiplication thing there. So we are going to take the first, which I'm going to let 100x be my first function and y be my second function. So the first times the derivative of the second would just be 100x y prime. Plus, we're going to add to it the second times the derivative of the first. Well, the second function is just y, but what's the derivative of the first function? 100. So this would be 100y. So we'll pause right there and see if you have any questions regarding just the derivative so far.
But what about
So at this point, if I wanted to get y prime by itself, it would be a major burden of algebra. I would need to distribute everything on the left, and I would need to rearrange it so that I had just my y prime terms on one side and my non-y primes on the other. But because we're only being asked to find the slope, we're not also being asked to actually find the derivative. We can take the unsimplified derivative and go ahead and plug in the 3 and the 1 for the x and the y. And that will save us a lot of algebra. So let's see what we get. I'll keep the 6. I'll plug 3 in for x, and 3 squared will be 9.
Oh.
And then y squared is 1 squared. And then I have 2 times 3 is 6, plus 2 times y is 2, and I still have a y prime, equals 100 times x will become 300 y prime, and then 100 times y is 100. So double check behind me and make sure that I substituted properly so far.
So you wouldn't take it to the derivative of 1 for the y prime.
No, you don't substitute anything for y prime. Y prime is what you're trying to find.
Oh.
Once you isolate that y prime now, that will be your slope.
Okay.
So we went ahead and we plugged in, and we have 6 times 10, so this would be what?
60.
So that's 60 multiplied by 6 plus 2y prime is equal to 300 y prime plus 100. So we're getting a little closer. So really we have 360 plus 120 y prime. You can't stop until you isolate y prime. Equals 300 y prime plus 100. And now that I have it down to there, I can get the y primes together and solve for y prime. So I'm going to pause for just a second and let you figure out what you get when you finally do isolate the y prime and find the numerical derivative, which is known as the slope. So at this point, I'm going to move the 360 to the other side and the 300 y prime over here. So when I rearrange that, I get negative 180 y prime equals negative 260. Is that right?
Yeah.
Okay. And I'll divide both sides by negative 180 so that the slope, or y prime, will be negative 260 divided by negative 180, which is really positive 26 over 18, which will simplify further. They're both simplifiable by 13, right?
Yeah.
Yeah.
Well,
So
no,
that
not by 13.
by 2, and it will simplify down to 13 over 9. Or if you give it to me as a decimal, what is that? Repeating force, or 1.4 repeating. So that's what we're looking for there. So here we want to find the second derivative with respect to x of the circle x squared plus y squared equals 25. And for our first derivative, we get 2x plus 2y prime is equal to what?
0.
0. Remember that the derivative of 25 is 0. Then we'll isolate the y primes, and we'll divide both sides by 2y, and we will get y prime equals the opposite of x over y. And we're not going to stop there, but I do want you to kind of bubble that in because you're going to need it later, unfortunately. And then we just start over. We ask ourselves, if we want to take the derivative of y prime, what's the derivative of the first derivative? What's the derivative of the first derivative?
Quotient rule.
The second derivative, right?
Yeah.
So the derivative of y prime is y double prime, or y d2y over dx2. So we're just going to notate it as y double prime, which is what we're being asked to find. Now to do that, on this side, I do need the quotient rule. So we're going to go low d high, which would give me negative y minus high d low. So minus a negative x makes positive x, and then d low is y prime, all over low, which is y squared. So I'm going to go through that one more time.
Whoa.
I did the low and the high, and I did d low, and got y prime, and I did d high, and got negative 1. Then I multiplied low d high, so that was negative y. And then I said minus high d low, so minus negative x y prime, so I've changed that to a positive, over low. That is my second derivative, technically. So your calculus is done. But what you need to know is that you can't stop with derivatives inside of derivatives. You must now make a substitution, and everywhere you see a y prime in the second derivative, you must substitute it with this thing I put the cloud around. So now I must substitute this into my second derivative so that I have it all in terms of x's and y's rather than x's, y's, and y primes. So that will give me negative y plus, if I multiply x by negative x over y, do I get negative x squared over y? Okay, so that's a negative x squared over y, all over y squared. Unfortunately for us, we have just spent great deals of time, right, trying to figure out ways to get rid of complex fractions. And all we have to do to finish this up is to multiply everybody through by what? Y. So we're going to multiply through by y, multiply by y, multiply by y, multiply by y, and that will give us our final second derivative, which is negative y squared minus x squared over what? And be careful not to oversimplify here. You can't reduce this y squared and this y cubed because you can't reduce from all of them. In order to do that, we would need to be able to factor a y out of the top and then reduce it with the bottom. So this is as far as it goes. So they're not that bad. You just have to remember at the end to substitute for your y prime. For our final example, we want to find the tangent line. That means I'm going all the way to y equals mx plus b. To the curve x squared onto x squared plus y squared equals y squared at the point square root of 2 over 2, comma, square root of 2 over 2. So in order to find the tangent line, I first have to find the derivative and then convert the derivative to a slope and then use the slope to substitute into point slope so that I can find the equation. So this is going to take a little time. First thing is, rather than doing the product rule to the left side, it's an easy distribution. So do you guys mind if I go ahead and change that left side to x to the 4th plus x squared y squared? Okay, so let's do a little bit of algebra first. X squared? Nope. Definitely not x squared. If we distribute, what do we get?
X to the 4.
Let's use.
So we distribute and we get x to the 4th plus x squared y squared equals y squared. We'll go ahead and take the derivative at this point, and this one will give us 4x cubed. And this needs the product rule, so I'm going to do it with you. First times the derivative of the second. I'll go over here and do it just so we're clear. We have the first and the second. So the first is x squared and the second is y squared. And the derivative of the first is 2x, and the derivative of the second is what? 2y prime. Okay, so I need to write down first times derivative of the second. So that would be 2x squared y prime. Whoa, okay. 2x squared y prime plus the second times the derivative of the first, which would be plus 2xy squared, equals 2y prime. Okay. All right. So there's my derivative. We even had to use the product rule in the midst of it. And at this point, I have to make a decision. Because I am going to take it to a numerical derivative, I could plug the point in now. That point, however, is not pretty. So, you know, it could go either way. I could plug the point in now, and then I'm still forced to isolate y prime. I don't think this one's that bad, so I think I would rather go ahead and isolate y prime now, if that's okay with you guys. Is it? Or do you want to plug in? We can do whichever one you want. Isolate? Okay. So let's get the y primes together on the left. So I'll take this term and put them on the left. And then I'll take these two and I will move them to the right. So those will equal negative 4x cubed minus 2xy squared. I'm not sure, you guys. I think we may have made a mistake. I think we should just plug in. What do you think?
I think I'm done.
You just think you're done for the day? All right, let's just keep going. We're almost there now. So if I factor a y prime out of this side, I get 2x squared y minus 2y equals this guy, negative 4x cubed minus 2xy squared. All right, so what does y prime equal?
Y prime equals negative 4x.
A negative 4x cubed minus 2xy squared all over 2x squared y minus 2y.
Yeah.
Okay, so negative 4x cubed minus 2xy. Uh-oh, this is bad. All over 2x squared y minus 2y. And that is reducible by what? 2, yeah. So I could definitely take a 2 out of the top and bottom. You want to do that?
Sure.
Okay, so here's where we are algebraically. We have negative 2x cubed minus x times y all over x squared y minus y. That is our derivative, I think. So we've corrected our derivative, we have a derivative, and we need to convert that to a slope. So this is going to take a little bit of algebra. So I'm going to come over here to the side. I'm going to plug in square root of 2 over 2. Ready? Okay. I have on top negative 2 multiplied by the square root of 2 over 2 quantity cubed minus the square root of 2 over 2 multiplied by the square root of 2 over 2 quantity squared. Awesome. All over that squared multiplied by it again minus one of those. Oh my. Is that what I'm supposed to have? That's evil, don't you guys think? Hey, I have an idea. Let's cancel a square root of 2 over 2.
How about
Can we do that? They all have one, right?
Right.
Could I cancel one?
Yes.
I think, let's try it. So we now have negative 2 and just square root of 2 over 2 squared, which will be a lot easier. Minus, we cancel one of these, and we have square root of 2 over 2 squared, all over square root of 2 over 2 squared, because one of those canceled, minus 1. Okay, so it's getting better. So I'm going to pause and see if you can get a number out of that for me. So at this point, we think we have negative 2 times 1/2, which is what? Negative 1?
Yes.
Negative 1 minus 1/2 all over 1/2 minus 1. And if we clean all of that up, what do you guys get for the slope?
3.
Is everybody sure that that's 3?
Yes.
Yes? We're all confident?
Yes.
Okay, so our slope is 3. So all of that work to get us a slope of positive 3. And at this point, I now have to do what with it?
mx plus b.
Put it into point slope and turn it into the equation of a tangent line. So see if you can do that. It shouldn't be that bad after everything else you've been through here. So we will take that slope and we will put it into point slope with y minus y1 equals in parentheses x minus x1, close the parentheses. If y minus square root of 2 over 2 equals 3x minus 3 square roots of 2 over 2, we'll add the square root of 2 over 2. So we have y equals 3x minus 3 square roots of 2 over 2 plus 1 square root of 2 over 2, which will simplify to what? Negative 2 square roots of 2 over 2. So just really what? 3x minus the square root of 2. Yes? That is the equation of your tangent line. If you can stick with a problem like this and get it on your own, you can consider yourself quite accomplished in calculus.